Hello Dakota, this is Miss Tracy. So let's look at lesson 111 where you were having some trouble. So we're asked here to graph 6 is less than or equal to x minus 2, which is less than 7, and the domain is real. So that's important. That tells me that we're going to be using a line, right? So the first thing we need to do is get x all by itself. There's no negated inequality signs. So we move on to getting x by itself. So in order to do that, I have x minus 2. I have to add 2 back in order to get x back to x, right? So plus 2 to each section, so all 3. So this gives me 8 is less than or equal to x, which is less than 9. So I'm going to circle the 8, and I'm going to circle the 9. X is going to live in between, and now I'm going to look at my inequality. This has an equal sign, so it could be 8, but this one does not have an equal sign. So think of that equal sign, that little line underneath, as telling you to fill in the circle for this end of the conjunction. So we fill in the circle for the one that has the little line under it. If it doesn't have the little line, we don't fill in the circle, okay? And that's when we have reals. So let's look at the next one. So this next one says to graph negative x is greater than negative 3, or x is greater than or equal to 7 in the domain of integers. So that means we're just doing the whole numbers on the number line. So first I've got to change this negative x, because we don't like to have negative x. We like to have, this is saying, what's the opposite of x? Well, that's confusing. We don't want to know what the opposite of x is. We want to know what x is. So we're going to multiply this times negative 1. Everything in here is going to be times negative 1, right? So negative 1 times negative x is x. Negative 1 times is just asking for the opposite. The opposite of greater than is less than. And the opposite of negative 3 is a positive 3. So that one is where we can actually make sense of it. And now we've got x is greater than or equal to 7. That one is fine by itself. We don't have to do anything to it. So now we look at the domain of integers. X is less than 3 in integers means we're going to graph all the integers that are less than 3. So 2 is less than 3, 1 is less than 3, 0 is less than 3, and on and on. And x is greater than or equal to 7. So it could be equal to 7, but it's also greater than 7. So all the integers on and on and on that are 7 or more. And that's how you would graph that one. So let's look at the next one. Okay, this one is asking us to graph 0 is less than or equal to x plus 6, which is less than 11, and the domain is integers. So we've got to get x by itself because that's what we want to graph. We want to graph what x is, not what x plus 6. So if we're adding 6 to x, to get back to x, we have to take that 6 away. We need to do that to all of these sections here. So that would be negative 6 is less than or equal to x, which is less than 5, because 11 minus 6 is 5. So this is what we're going to graph in integers. So if negative 6 is less than or equal to, we circle that, and because of that little line, that tells us to fill it in, right? And so that is less than 6. So we're going to graph the integers that are greater than 6, negative 6 and greater, but x is less than 5, so we can only go up to 4 because we're doing integers. So we would fill in all of the integers until we get to 4. If we were to go to the next integer, that would be 5. We can't include it. We can't even mark it. It has to be the way it is. So we stop right there. We don't circle the 5. We leave it alone. If this were reals, we would circle the 5. But because it's integers, we do not do anything to 5. We leave it alone. Now, if this had said equal to 5, then we could have included the 5. But it doesn't. It does not include the 5. It tells us less than 5. So we don't do anything to it. All right, we just move on. So let's look at the next one. So this one is asking us to graph x is less than -1 or x is greater than or equal to 5 in reals. So this is where we're going to draw the line. So let's circle -1 and we'll circle 5. And if x is less than -1, then we would go to this direction and we would put our little arrow there. And if it's greater than or equal to 5, we can fill in the 5 because we have that equal sign. And then we'll go in this direction and put our arrow because we're going to be greater or equal to 5. And we do the line because it is reals. All right, let's look at the next one. This says Homer drove as fast as he could to get 60 miles ahead of May. If Homer drove at 17 miles per hour and accomplished his goal 20 hours after they both began, how fast did May drive? So here's the picture of what Homer was trying to do. And here's May. So Homer was trying to get 60 miles ahead of her. So he wanted to be here, which was at a location where May's here and there's 60 miles. And he's 60 miles ahead of her, of where she is, right? There's a 60-mile difference. So the distance of Homer is equal to the distance of May plus 60 miles. You can see his distance is the same thing as May's distance, and then he's 60 miles ahead of her. That is the picture of the equation that we need to do. And then from there, we break it down into our dirt. Distance equals rate times time. So distance equals the rate of Homer times the time of Homer. And the distance of May is equal to the rate of May times the time of May plus 60. Now, we have the second sentence that says, if Homer drove at 17 miles per hour and accomplished his goal 20 hours after they both began, how fast did May drive? So we have two things given to us. We have rate and time, and we have Homer and May. We have Homer's rate. So the rate of Homer is 17. And their time is 20. Both of them are 20 because they both began at the same time. And it took 20 hours for him to accomplish his goal. So they were both driving for 20 hours. What we don't know is the rate of May. Okay? So we can start dropping this information in. So we know the rate of Homer is 17 and the time of Homer is 20. We don't know the rate of May, but we know the time of May is 20. So now we can do some calculations. We've got 17 times 20, that's going to be 340, is equal to 20 times the rate of May, just because we like to have the variable last, plus 60. So if I subtract 60 from both sides, then I get 280 is equal to 20 times the rate of May. If I divide both sides by 20, then I get that 14 is the rate of May. So she was driving 14 miles per hour. That is her rate, 14 miles per hour. That would be your answer. Okay, let's look at the next one. All right, so here we're looking to find the volume of the right triangular prism below. Dimensions are in meters. So first we have to look at what is the formula for volume. And the formula for volume is equal to the area of the base times the height. it is always area of the base times the height. So once you find the area of the base, you multiply it times the height. So when you have something like this, you have to figure out what is the base. The base is going to be the shape that is consistent throughout. So in this case, the shape that is consistent throughout is the triangle. If you were to flip this over and put the triangle on the bottom, you would have a triangular column. So it is like, just if you were to have a cylinder, you know, your base would be a circle, right? It's the same thing here. It's like somebody flipped it over on its side. The circle is still the base. So it's the same thing here. The triangle is the base. It's the one that's consistent. It's the one that looks like somebody took it and just stretched it out, right? Pulled it up. Same thing for the triangle. Somebody took this triangle and they extruded it, right? They pushed it through. If you ever played with one of those Play-Doh things where you have the circle and the square and the triangle, and they push the Play-Doh through the little thing and they make like a little triangular worm or a circular worm cylinder, right? It's the shape. The overall, like if you were to slice it, what shape would be throughout the whole length? And in this case, if you were to slice it here, the shape that would be consistent through the whole length is the triangle. If you were to slice it this way, you wouldn't have a consistent shape. You would have something different on the top, something different on the bottom, right? The left and the right would be different. So it's all about what is the area of the base. So, all right, I'm assuming you get that. So we take the area of the base, and it's a triangle. So we find the area of a triangle, which we know is base times height divided by 2. So the base is 10 and the height is 12. So we say 10 meters times 12 meters. We divide that by 2. That's 120 meters square divided by 2 to be 60 meters square. So now that we have the area of the base, we put that back in. We get volume is equal to 60 meters square times the height. Well, in this case, it's length because it's like the column got flipped over on its side, right? So it would be this dimension, 15 meters. So times 15 meters. And 60 times 15, that would be 10 times 60 would be 600. And then 5 times 60 would be half of 600, so it would be 300. So we are looking at 900 meters, and it's going to be cubed because it's volume. Meters twice, meters one more time, 2 plus 1 is 3. So 900 meters cubed is what we would have for the volume of this right triangular prism. So let's look at lesson 114. All right, here we are in lesson 114. Harriet deposited $900 at 8% interest compounded annually. So we're going to use this formula. The amount in a certain period of time is equal to the original amount times 1 plus the interest rate in that time period. So we're going to add in the numbers. So we're going to write an equation that tells how much money is in the account after n years. Farthest equation to find the amount in the account after 12 years. Okay, so apparently I've got some typos going on. I'll fix those. We want to find the amount in the account and then how much total interest is what we're wanting to find. So I'll fix those. But we're looking for 12 years. $900 at 8% over 12 years. That's our variables. So the amount in 12 years is equal to the original amount of $900 times 1 plus 8% in decimal form is 0.08 in 12 years. Okay, so that is our equation. So first we're going to do what's inside the parentheses, which is 1.08. Right, now we do our exponent. And that is going to be done on the calculator. Let me pull that up for us. So we're going to say 1.08 to the exponent of 12. And it gives us this. Now, I am not going to write that in here so much as I'm just going to go ahead and continue multiplying on the calculator, because we know that number is going to be multiplied by 900. So I'm just going to go ahead and say times 900. And I get $2,266.35. All right, so that is going to be whatever that amount is. $2,266.35. This is the amount over the 12 years, but we need to find the total interest. So we're going to subtract. We're going to bring that original amount of 900 out of here. So we bring up our calculator again, and if I just subtract minus 900, then I get 1366.35, right? So 1366.35. This is my interest. That's what we're looking for. All right, the number of bacteria in the Petron, that should be Petri dish. So that was the typo, autocorrect also. It quadrupled every hour. There were 1,000 bacteria at t equals 0, so time equals 0, so the original amount. How many bacteria were there in 24 hours? Write the answer in scientific notation. So we're not given an interest rate here. Instead, we're giving a rate of growth. So the difference between a rate of growth and an interest rate is there's no decimal format. So we don't add 1 to it to include the original number. Instead, we say the amount over time is equal to the original amount, or the original amount, 0, times the rate to that amount of time. So the amount of time would be 24 hours. The original amount is 1,000. The rate quadrupled is a way to say times 4. And again, we're going to do 24 hours because that is the rate every hour. So that's every time it quadruples is 24 times. So this is what we're going to do. We're going to pull our calculator again. And we're going to say 4 with an exponent of 24. That's a big number. I'm not writing that number down. I'm going to leave it in the calculator. So we've done this part. So now I just need to multiply it by 1,000. So times 1,000. And it's going to tell us 2.8. It's already in scientific notation for us. This is the exponent, e, the base e. Remember logarithms? It's the base e. So 2.8 to the exponent of 17. So that's what it's telling us, that A24 is equal to, let me write that down, 2.81 times 10 to the power of 17. That's our answer. All right, Allegra deposited $700 at 9% interest compounded annually. What was the total interest earned? That's what we're looking for in 11 years. So the amount in 11 years is equal to the original amount, $700. This is a percentage, so we're going to do 1 plus the 0.09 for 11 years. So that's equal to 700 times 1.09 to the 11th power. So we're going to do all of this in the calculator at the same time. It just makes life easier if we do it that way. So we do 1.09 to the 11th power, okay, times 700. That gives us $1,806, and this rounds up to 30 cents. So 1806.30. That is the amount in 11 years. But it doesn't want to know the total amount. It wants to learn the total interest earned. So we're going to subtract the original $700. And that gives us $1106.30. That's what it's looking for. That is going to be your answer. All right, here is the one of the other problems. This is a distribution problem. We're going to distribute everything in this binomial to this binomial. So we're going to say 3 times 3 minus the square root of 2 plus 2 times the square root of 2 times 3 minus the square root of 2. Okay. So that's how that works. So 3 times 3 is 9, and 3 times the negative square root of 2 is a negative 3 times the square root of 2, plus 2 times the square root of 2 times 3 is 6 times the square root of 2, and then 2 times the square root of 2 times the negative square root of 2 is a negative 4, because negative or positive square root of 2 times the negative square root of 2 is a negative 2. And 2 times the negative 2 is a negative 4. So 9 minus 4 is 5. And a negative 3 times the square root of 2 plus 6 times the square root of 2 is a positive 3 times the square root of 2. And that would be your final answer. Sometimes it helps to break it apart so that you can be less, makes you more organized. You're less likely to skip something if you separate it. So you only have to do this once, twice, and it's just kind of easier to see. So it's kind of like undoing, you know how we do that group factoring where we factor it to where we take the factor out, and then we have the same thing with this factor and the same thing with this factor, and we put these two together in a binomial. It's the opposite of that. We're undoing that in order to make distribution simpler. That's all it is. All right, let's look at the next problem. All right, so this problem asks us to factor 4x squared plus 4x plus 1. Well, the only thing that I can think of is because we have a coefficient here, we can either divide everything by 4, or we can use the 4 times 1 to get the middle term, right? So you take the first term and the last term, you multiply them together, and we get 4, because 1 times 4 is 4, right? So now we have to think about what factors of 4 we can add together, and this is positive 4, to get 4. Well, I can right off the top of my head, positive 2 times positive 2. If we add these two together, it gives us positive 4. So I can split this up and say 4x squared plus 2x plus 2x plus 1. Really straightforward. All right, we know if we combine these two, we get this. So now I can factor out of here. I can factor a 2. So if I say 2 times, actually I can factor out 2x. So let me undo this. I can say 2x times 2x plus 1, right? 2x times this would give us this, and 2x times this would give us this. And now we've got 2x plus 1. I can't really factor anything out except for the identity property, because 1 times 2x is 2x, and 1 times 1 is 1. So what I end up with is 2x plus 1 times 2x plus 1. So when we go over here to the pod, that's what we put in here. We put in 2x plus 1, and then 2x plus 1. If I can type in the right symbols, that would be great. And check it, and they're both right. All right, so let's look at the last one that you struggled with, which was this one. So let me copy that over. All right, so this one says that the base of a right solid 5 feet high is shown. Find the surface area and the volume of the right solid. Dimensions are in feet. Formula for a regular octagon is this. So this is the area of a regular octagon. So we're going to find the area of the base here. That's what we're going to do. So all we need to do, where A is the length of one side. So in order to find the area of this base, we say the area is equal to 4.8284 times 5 feet, because A is the length of one side for a regular octagon. So that's all we have to do to find the area of the base. Okay, so I'm going to pull up my calculator and let's clear this out. And I'm going to say 4.8284 times 5. 24.142. Okay, so 24.142 feet is the area of the octagon. And I'm just going to say 8 for the octagon. So there's my area. Oh no, it's not. Never mind. Sorry. I missed that. It's squared. Squared. So I've got to multiply it by 5 again. So times 5 again. 120.71. All right, now I have the area is 120.71. That would be like something else. So this is feet squared. So that's where I messed up. I forgot the square on the A because it is area, so it has to be squared. All right, so 120.71 feet squared is this times 5 times 5 times feet times feet. So there's the area of the base. Now we know that goes here, 120.71 feet squared. We know we take the area of the base and we have it here and we have it here. So we have a bottom and we have a top. So that means we need to find the surface area. We need to say 2 times the area of the base, which is 120.71 feet squared. All right, so 2 times the area of the base, plus the lateral surface area. Now, if this is a regular octagon, then every side has a length of 5 feet. And it says it's 5 foot tall. So every side is going to be 5 by 5, right? And in an octagon, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So the lateral surface area is going to be 8 times 5 foot times 5 foot. Right? So we've got these 8 5 by 5 panels all the way around, or sides all the way around. So we can say 5 times 5 is 25. 8 times 25 would be 200, because 4 times 25 is 100, so that's twice as much. So 8 times 25, that's going to be 200. So plus 200 feet squared. And this is twice that. I think it's still in the calculator. So now we just have to multiply that by 2 times 2. 241.42. Okay, so 241.42 feet squared. So now we just add 200 to that. So that's going to equal 441.42 feet squared is the surface area. Right? That's the total surface area. So that goes here. 4, this is just a cursor. Ignore that. Actually, let me put... Hang on. There we go. Now you really can't see it. All right, so 441.42 feet squared goes in that box. Now, to find volume, we know volume is equal to the area of the base times the height. So the area of the base, we have it here, 120.71 feet squared times the height, 5 feet. So we're going to multiply that. So we go back to the calculator. 120.71 times 5, 603.55. So 603.55 feet cubed. That would be the volume. So 603.55 feet cubed. All right, so it's all about, in order to find the area for this, it's all about just using the formula that you're given and being able to apply that exponent that, I almost didn't, but being able to see it for what it is, put that 5 foot in there and square it. And that's how you find the area of the base for a regular octagon. So you really didn't have to know how to do that part. You just needed to know how to get total surface area and how to get volume. And the rest of it was should have been pretty easy. All right, so that should be all of what you needed for lesson 111 and 114. If you have any other questions, please feel free to ask.